So question 9a, we have a real world example, right? So we know integrals give us the total accumulation. So this would give us the total accumulation of money that was compounded continuously, right? You might kind of recognize it as like that PE to the RT formula, right? So in a sense, what this is, right? So here's our E to the RT. We know you might remember A equals PE to the RT. So what this here is representing what the P would be, right? That kind of present amount of money that you have at any point in time. So I just do this thing to Desmos. Nothing crazy here, right? So here's our antiderivative. If we threw in a 5, boom, that's how much money we would have. That's how much our $1,000 would be after 5 years, 10 years, that much, 25 years, that much, right? So it just kind of shows again, the importance of exponential growth, right? This is how so many different things in kind of like the financial world works, like your retirement, your IRA, like all of that stuff that you probably have no idea about because I don't know, you probably don't think about like your retirement funds at this point. Just saying, not trying to like retirement shame you. Just I'm probably close to. I'm gonna shut up now and just go to the next question. So when we look at the next question, so we have this capital asset, and this is so what this capital asset is basically the amount of money that you'd have to like invest into an account at some point in time nowadays in order to end up with a um I forgot I was saying I was such thinking about like my retirement now. So basically, what this is doing is this would be the amount of money that you would have to invest into an account and just let it sit there, right? So if I had some account that I was earning, if I was putting money into continuously, right, and I wanted to say, well, how much money would I have to just invest in a different account earning the same amount of interest, but not add money to? That's what this capital asset is. That's what this kind of like capital value of an asset is. So if we looked at say this, right? So here's our formula, right? Since we don't know when we're going to die, we kind of treat this as an asset for perpetuity, right? Forever and ever and ever and ever. So suppose we have this earnings, right? So you're making $10,000 in this like lottery thing that I said. So we're going to have the antiderivative from 0 to 10,000. So we have E. Whoops, whoa, that's not 10,000, that's infinity. 10,000, which I'm going to pull out in a second, e to the negative 0.08 t dt. All right, so when we pull this out, when we kind of rewrite this in terms of an improper integral, we're going to end up with the 1,000, 10,000 times the limit as r approaches infinity of 0 to r e to the negative 0.08 t. All right, so when we take this antiderivative, this is going to be negative 1 over 0.08 e to the negative 0.08 t evaluated from 0 to r. We still have this limit, and we still are multiplying everything by 10,000. All right, so let's see what we get here. So when I plug in some r's, I have a 10,000. I have a limit as r approaches infinity. I'm gonna pull that negative 1/8 out as well. So let's get rid of this thing. This is going to be negative 1,000 over 0.08. So when I take this antiderivative, remember I have e to a negative. So this is the same thing as 1 over e the 0.08 t. So I'm going to get 1 over e to the 0.08 r minus 1 over e to the, well, 0. So when r gets really, 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 really large, so I take this limit as r goes to infinity, since we have an exponential that's being raised to a power, even if I'm taking 0.8, 0.08, 8 hundredths of something getting very large, that's still getting really large, right? So this first term just tends off towards 0. So this second term, well, it's obviously equal to 1. So I have negative 10,000 over 0.08 times negative 1. So that's going to be 10,000 over the interest rate and 10,000 over 0.8. Can I do it in my head? I can probably do it in my head. That's the same as 8 over 100. Right, so 8 over 100 is going to be 10,000 times 100 over 8. Right, that's going to be 12.5. So we're going to get 12, and we're going to move that decimal over 5 places. So we're going to get 12, 5, 0, 0, 0, 0. 1.25 million. That sounds about right. So what this would mean is that if I were trying to purchase this, say your lotto winnings for the rest of your life, right? So what I would offer you would be 1.25 million for it, right? So your $1,000 that's getting put into some sort of annuity from now to forever. For me, it's worth $1.25 million. So obviously, I wouldn't offer you $1.25 million. I wouldn't make any money off of it. What if you died? Right. So this is where kind of like settlements, like what's that guy, like JP Wentworth, for all my New Yorkers out there that know those commercials. Like you would offer something less, right? You would offer, I don't know, $80,000, right? Whatever the risk factor is that your underwriter said you should offer, that's what you're offering this person to buy this kind of like perpetual annuity for you. So that's it. That's some real world stuff. Ooh, gamma functions next. Can't wait.